What's up guys, welcome back to our channel, Pautastic. Today we are going to learn about Hess Law. What is Hess Law? Hess Law states that the enthalpy is independent of the number of steps involved in a reaction. Things you must know about Hess Law. Delta H is used symbol for enthalpy. If the delta H is negative, it is an exothermic reaction. If it is positive, it is an endothermic reaction. And the symbol used here is kJ or kilojoules. The final enthalpy is the sum of enthalpy changes of the reaction. So here is an example. Calculate the final enthalpy of A plus B plus D will yield to E given the following. So the first equation given is A plus B will yield to C with an enthalpy of 100 kilojoules, and the second equation is C plus D will yield to E with an enthalpy of 200 kilojoules. So here you can see that the first equation contains C on the product side, while on the second equation, the C is on the reactant side. They can both be equated to 1 and subtracted to each other, which will yield to removal of C. So A plus B plus D will yield to E. To get the final enthalpy, you just need to add the enthalpy of equation 1 and equation 2, which will yield to 300 kilojoules. So the final answer is A plus B plus D will yield to E with a final enthalpy of 300 kilojoules. So there are two principles under Hess Law. The first principle states that whatever you multiply to the reaction, you need to multiply it to the enthalpy. So here is an example. N2 gas plus O2 gas will yield to NO2 gas with an enthalpy of positive 181 kilojoules. So as you can see here, we multiplied the reaction by 2. So the enthalpy must as well be multiplied by 2. And the final answer will be 2N2 gas plus 2O2 gas will yield to 2NO2 gas with an enthalpy of 362 kilojoules. So next example is 6CO2 gas plus 2H2O gas will yield to 4CH4 gas plus 2O2 gas with an enthalpy of positive 890 kilojoules. So as you can see here now on example number 2, the equation is multiplied into 1/2. So the enthalpy must as well be multiplied to 1/2. So the final answer will be 3CO2 gas plus H2O gas will yield to 2CH4 gas plus O2 gas with an enthalpy of positive 445 kilojoules. So the second principle states that whenever you reverse the reaction, the sign of the enthalpy is reversed. So here is an example. HCl gas will yield to HCl aqueous with an enthalpy of negative 74.8 kilojoules. So we just need to reverse the position. The product side will now go to the reactant side, and the reactant side will now go to the product side. So HCl aqueous will yield to HCl gas. As the second principle stated, when the equation is reversed, the enthalpy symbol or sign is reversed as well. So the negative 74.8 kilojoules is now positive 74.8 kilojoules. So here is a second example. C solid plus 2H2 gas will yield to CH4 gas with an enthalpy of positive 75 kilojoules. Again, put the product side on the reactant side and the reactant side to the product side, and reversed the symbol or the sign of the enthalpy. It will be now CH4 gas will yield to C solid plus 2H2 gas with an enthalpy of negative 75 kilojoules. And now, let's proceed to solve it. Problem number 1. Calculate the enthalpy for the reaction 2PbCl2 solid will yield to Pb solid plus PbCl4 liquid, given the first equation is Pb solid plus Cl2 gas will yield to PbCl2 solid with an enthalpy of negative 223 kilojoules. And for the second equation, PbCl2 solid plus Cl2 gas will yield to PbCl4 liquid with an enthalpy of negative 87 kilojoules. Feel free to pause the video in order for you to answer it on your own. And now, let's proceed to the solving. As you can see, the first equation must be reversed so that we will yield to 2PbCl2 solid on the reactant side. And the sign as well of the first equation will be reversed, so it will be positive 223 kilojoules. As what we've stated on the beginning, there is a Cl2 gas on the first equation product side, while Cl2 gas on the second equation reactant side. So feel free to cancel that. So now we will have 2PbCl2 solid will yield to Pb solid plus PbCl4 liquid that will yield to the enthalpy of positive 136 kilojoules, since we were going to add 223 kilojoules with a negative 87 kilojoules. And now I am going to leave you with a question. Feel free to answer it on your own. That's all for the Hess Law lesson for today. Thank you for watching.